Lesson 4.2, shape of a distribution. Our objective for this lesson is to be able to describe the shape, symmetry, and variation of a distribution. One way to describe the shape of a distribution is by its number of modes or peaks. A unimodal distribution has a single peak, whereas a bimodal distribution has two peaks. This is important because it might not be as meaningful to talk about the average of a bimodal distribution as it would be to talk about the shape of the distribution. For example, if you're talking about the number of customers in a restaurant at any given time, you're going to have a lot of customers around lunchtime. You're going to have a lot of customers around dinner time. It's not going to make much sense to say the average time that people come to the restaurant is 3 o'clock in the afternoon. But instead, you're going to want to describe those two peak times in your distribution. So that would be a bimodal distribution. The graph of a unimodal distribution might look like this with just a single peak. The graph of a bimodal distribution might look like this with two different peaks, though one might be smaller than the other. It's also possible to have more than two modes, or to have no mode at all, which would be a uniform distribution. Another way to describe the shape of a distribution is by describing its symmetry. A distribution is symmetric if its left half is a mirror image of its right half. So the shape of a symmetric distribution will be the same on one side as it is on the other. On the other hand, a skewed distribution has values that tend to be more spread out on one side than on the other. So a left skewed distribution has values that are more spread out on the left side, and a right skewed distribution has values that are more spread out on the right side. For a symmetric distribution, the mean and median will be at about the same place. For a left skewed distribution, the mean will be to the left of the median. And for a right skewed distribution, the mean will be to the right of the median. A third way of describing the shape of a distribution is by describing its variation. Variation refers to how widely data values are spread out from the center of a data set. So a distribution with a low variation is going to have most of its values clustered really closely to the median of the distribution, whereas a distribution with a high variation is going to have its values spread out over a much wider range. The graph of a distribution with a low variation is going to look like this, with most of the values clustered around the median. The graph of a distribution with a high variation will look more like this, where the values are much more spread out. For our examples, we're asked to make a sketch of what we would expect the distribution to look like, and then to describe the symmetry and the variation of the distribution. So for our first example, we have ages of patrons who visit an amusement park. And so for this one, depending on the type of amusement park it is and what age group the amusement park is geared toward, you might see a bimodal distribution here, where you're going to have a lot of young kids, and then you'll see another hump here for their parents, and then you might see this kind of taper off into much older ages. So I would expect this to be a bimodal distribution, especially if it's an amusement park that is really geared toward young kids, because the young kids can't show up by themselves. They've got to have their parents with them as well. So you're going to have young children, and then a group of adults that are around about the right age to have young children. So bimodal graph. As for the symmetry, we would expect it to be skewed to the right. And the reason for that is that since we're expecting to see a lot of young kids, there's no way for the values to be spread out to the left. The only place for values to be spread out would be to the right with the older patrons. As for the variance, I would expect the variance to be pretty high because, as we said, you're going to have both young children and their older parents. And if it's an amusement park like Disneyland, you could expect that patrons from infant all the way up to the elderly are going to be able to enjoy that amusement park, and so the variation is going to be pretty high. The second distribution we're asked to describe is scores on a difficult math test. So for a difficult math test, we're going to expect the average score to be a little bit lower, so maybe in the C range. And so maybe you have relatively few A's, a few more B's, and then peak in the C range and then come back down into D's and F's. And the reason that I said a difficult math test, when we're talking about the symmetry, I would expect a difficult math test, the distribution of those scores to be relatively symmetric, with few A's and few F's, and more of the results clustered around this median of a C. So I would expect it to be symmetric, and I would expect the variance to be moderate, not really low to where everyone's getting a C, but not so high that we're expecting plenty of A's and plenty of F's. So I would expect a moderate variance and a symmetric graph. Now, had I said scores on an easy math test, well then this median, this peak, would be more in the A or B range up here. Then we would expect it to be skewed to the right. And the reason for that is because we're bumping up against this maximum grade here. The maximum grade would be an A, and so there's no room for the values to be spread out to the left. The only place for values to spread out would be to the right. And so an easy math test would be right skewed. But for this difficult math test, I'm going to assume that the distribution would be symmetric and with a moderate variance.